Hello guys, and welcome back to my channel. Maybe you already noticed what I have here, but if you don't, I will tell you that it's an Impulse Wolf PDB. But before I get to that, I want to tell you the story of how I got this one, and I also have another one. I was talking with Impulse a while ago about if they could send me the unpopulated PCB and build it on a video. Unfortunately, they couldn't provide me with an unpopulated PCB, and that's because of course the PCBs are manufactured in a factory, so it's pretty hard. But instead of that, they said, oh, you know, we will just send you some that didn't pass the QC and find out what's wrong with them. So I have here two PDBs. One I will give away to one of you guys, but I will get to that at the end of this video. So I just mounted this in my rig, decided not to solder any wires, because if this one goes out to one of you guys, I want it to be like new, so I just use some alligator clips there. So in manufacturing, usually after all the parts are placed and all of that, they go into a jig, which is like a template with connections for all the pins and stuff like that. They check all the connections, if everything is okay. They also flash the microprocessor, which in this case is an F3 processor here. And sometimes they just don't pass the quality control check at the end, and that's from a couple of possible reasons, like the bootloader wouldn't flash, or the main firmware didn't flash correctly, or there is some issues with the power on this board. If you didn't know, Impulse had a previous PDB called the Mr. Steel PDB, which was similar to this one, but on this Wolf PDB they chose to go a step further and install a bigger processor which can cope with a lot of other things. For example, you could mount a GPS, you could control the camera, you could also control the VTX and so on. So of course they needed a bigger processor and more capable one, because the original design of the Minim OSD was with an Atmega 328, I guess, or something like that, from Atmel. If we look to the overall design, it has some interesting stuff on it. And if we look here on the left side, all this section here relates to the first main regulator found on this board, which takes the LiPo voltage and reduces it to 7.5 volts. And because switching regulators produce some noise, and that's mainly because of how they work. After they generate the 7.5 volt, which will be used also to power an HV VTX, they put that through this linear regulator, which outputs 5 volt at 1.5 amps. And from here they can power the camera, the OSD chip, and also here there is a 3.3 volt regulator, which I assume it powers the MCU. The other two things we can see here besides the OSD chip is an current sensor, and I guess this one is the microphone amplifier. I connected my alligator clips and I will try to power it up. If you power it up, you will see a green LED, which represents that the board gets some power, and it should be here another blue LED, which should flash, but in our instance is not flashing at all. So this makes me think that there is something wrong with the firmware or bootloader in the main processor. So to find out, there is a way of knowing if this board has the bootloader on it or not. And if you go to the ImpulseRC website, you will be redirected to this GitHub link, which is this one. And here you could actually see what all the pins are. And if we want to find out if the bootloader is present or not on the board, which is the most easy way to repair it, you have to bridge, while powering it, this SDA pin with the ground pin. So if we look closely, these two pins are the ones. So I am shorting them with my tweezers and powering the board. So it appears that this board is alive. If you see this red LED, not blue as I mentioned, is flashing. So from what the guys from ImpulseRC said to me is that if this is flashing, you could connect it to the software GUI, and that's what I'm doing right now. And you will be able to flash it, but as you can see here, it's not working. Okay, so it appears that the processor ID is not in the ImpulseRC database, and I guess that's normal because this didn't pass the QC. So I spoke with the guys, I sent them the device ID, and I will be able to flash it, but for now I will just power it down. Okay guys, so next I'm gonna power up the second PDB I have, and let's hope it's in the same situation. Yeah, nothing happens. So as I told you earlier, sometimes the main firmware doesn't get loaded from the factory for some reason, and if the bootloader is still present on the main processor, you can boot in the ImpulseRC Wolf PDB bootloader by bridging the SDA pin with the ground pin, which are these two. I'm holding my tweezers on, powering it up now. Unfortunately, nothing happens. So next I'm gonna try and put the F3 processor in native bootloader mode. I hope I'm explaining it right, and power it up now, connecting it to my USB. Unfortunately, the USB does not get recognized and has some problems, so I will power it down now. Just for the sake of it, I will power it and I will touch a ground pad, which is this one, and I will check the input on this linear regulator. This pin would be the input, so I should have here 7.5 volts, which I have 7.48 volts, and at the output I should have 5 volt, and I have 501, so that's okay. And we have here another regulator, which is for the MCU, I guess, 3.3 volts. This would be the pin for the input, and I have the same 5 volt, and this one should be the output, and I have 3.310, so it's okay. So the power rails for the PDB are working as expected, but something else is wrong with it. I guess maybe it's defective from the factory. So now for all you guys to understand why quality control is there, did any of you noticed something wrong with this processor? I personally just overlooked it, but for you to be able to see it, I will put the other good one next to it and try to grasp what's wrong with the bad device. Well, it's pretty easy. If you see here, we have a white dot on the PCB that should correspond to the pin 1 of the MCU. But as you can see, my dot on the MCU is on the other side. On the good one, as you could see, I have my pin 1 marker here, which corresponds to the marker on the PCB. So that means that somehow on the assembly line they kind of placed this chip 90 degrees rotated. The next thing I'm gonna do is just take out the processor and put it in the correct position, and let's hope that by placing it rotated 90 degrees it didn't receive some bad signals on the wrong pins and got killed. And because this is a bigger chip than usual, I'm gonna switch to a bigger nozzle on my hot air gun. I will place some flux on the pins, and because it's not the first time I replaced a chip similar to this one, I will show you another technique I use sometime where I don't use solder paste or soldering it by the soldering iron, and that's because I have a lot of parts close to the pins and I don't have too much space here to put my soldering iron. So I will do it only using the hot air gun, and because I don't want to ruin the connector, I will use some copper adhesive strips like this, just to protect it a bit by the heat. And now, as I explained you guys in previous videos, I'm heating up the board from a distance, and it will be quite difficult to heat up this board because it's a 4-layered PDB. Usually PDBs have more than 2 layers because they have to pass a lot of current from one side to the other. And next thing, if you have watched my previous videos, is to clean a bit the place from all those flux remains. Let me zoom in a bit just for you to see the actual thing that's happening. Next, I'm gonna clean all those little pads. And when I say cleaning, I'm thinking about removing all the lead-free solder, and that's because lead-free solder has a higher melting temperature. So that means that if I'm applying some leaded solder, it will melt and solder easier and at a lower temperature. So right now I'm just removing all that lead-free solder, just to be sure I removed it. Okay, I have one more here. Good. Now some more cleaning. And now just applying fresh solder to the pads. Apply as generously as you can. Okay, I touched this cap here, so I will remove that excess. Now, more cleaning. I have to say that I really like how they designed the PCB. Everything is lined up and placed in the optimum position. So thumbs up ImpulseRC for designing this PCB, I really like it. And now, I am not gonna use a soldering iron, but instead I am gonna just heat up the board. Again, I'm heating up the board before I'm placing the chip, because I don't want to unnecessarily heat up the MCU. Okay, and now I'm gonna place the MCU here and wait until it's connected to one or two pins on the board. Now, more flux. And more heating. It's not the most perfect alignment, but it's okay. Now we are letting it cool down a bit, removing this tape from here. The board is still hot, but it's okay. Now I'm gonna put my alligator clips back on the PDB, powering it up. As you can see, nothing happens with the status indication. So I'm gonna try and hope that it does hold the bootloader that they flashed, but most definitely they couldn't have flashed it because the MCU was in the wrong position. As you can see, nothing happens there. So the last option would be to put the processor in bootloader mode, like that, and plug it in to my PC. Find the diffuse demo. After some tinkering, I managed to flash the bootloader on this MCU, which appeared to be untouched, and that's mainly because it was rotated 90 degrees to one side. And now I will try to open the bootloader. Okay, so we have this serial number that I will send to ImpulseRC, exactly like the first one, and eventually later I will activate it and upgrade it the normal way through the GUI. I inserted the previous one, which had the microprocessor in its right position, but didn't had the main firmware written on it. So I sent yesterday the ID to ImpulseRC, and they were kind enough to insert it in the database. And I will jumpstart the bootloader by connecting SDA to ground again and power the PDB. We are starting the application. So as you can see, I don't have that error. So we have 19.8 latest version, and I will press update. And voila, we have the software connected here, where you can change a lot of stuff like your call sign, timer, RSSI, and stuff like that. What exactly to be shown on the actual screen. So yeah, I will not modify any of the settings right now. I have to say I really enjoy this this GUI they are using. Now let's power down the PDB, and you will see that now it will be working right from the start. So no issues whatsoever with it. Okay guys, so this one will go out to one of you. Only thing you have to do is just leave down a comment, only one comment, and in 1 week's time I will be recording another video where I will select using some sort of online comment chooser the one who will be receiving this PDB. I have to thank ImpulseRC for sending me these PDBs that didn't pass the quality control, and that's for a good reason, as you've seen that that one had the MCU in the wrong position. Thank you very much guys for watching. I hope like every time that this video was helpful to you, and see you next time. Bye.